So let's try solving another problem that uses Newton's second law. So we have two boxes here. Yung first box natin has a mass of 1 kilo. Tapos we have another box that is hanging on a rope that passes through a pulley and connected doon sa previous natin na box. Now, ang mass naman ng second box na ito is 1.20 kilograms. So it is slightly heavier than our first box. Now, we note, for simplicity's sake, na yung interaction between the box here, our first box, and this surface, it is now sliding on this surface, but our surface is frictionless. So, no need to take into account ano yung friction acting on our box here. So, we see that ang nangyayari dito sa ating setup is both boxes are moving. So, yung first box is moving to the right, and yung next box is moving downwards. Now, if nagmo-move ito sila together, and we expect that this rope is not stretching or compressing, hindi nag-change yung length niya, then we can observe that whatever is the acceleration of this box here, so if this is because of gravity, it is accelerating downward with a magnitude of A, then dapat yan din yung acceleration nung box sa taas para hindi mag-change yung length. So, dapat sabay silang mag-accelerate. Okay? So, we see here another example of objects with acceleration. So, hindi na natin magagamit yung Newton's first law. Ang gagamitin na natin this time is Newton's second law. Okay? So, let's try doing this problem. And what we are interested in finding out is the value nung acceleration na ito. Gaano sila kabilis mag-accelerate. Again, so they should have the same value. So, yun yung gusto nating isolve in this problem. Now, para hindi tayo ma-confuse, let us label these boxes here. This will be mass 1. And yung box dito sa baba that is hanging, we will label that as mass 2. Okay, so how do we go about solving itong acceleration na ito? So, like any other problems that we've solved before, our first step is to draw the free body diagram ng ating objects. So, we will focus first with mass 1. Okay, so we'll represent mass 1 with a dot. And then let's list down the forces. Of course, meron siyang weight and the direction is downward. And para ma-specify natin, kasi may isa pa tayong object mamaya, we will put a subscript 1 to indicate that this is the weight of box 1. What else? It is interacting with the surface, so meron siyang normal force acting on it. The direction is perpendicular to the surface, so in this case, it should be upward. Okay, so no need to put a subscript kasi wala naman atang normal force yung other box natin mamaya. Okay, so aside from this, we also have tension galing dito sa string connecting our two boxes. So the direction is to the right, and let's label that with T. Okay, so this is our free body diagram for mass 1. Now again, it will also be useful if we draw yung direction ng acceleration for box 1. So for box 1, ang acceleration niya is to the right, and the magnitude is A. Okay, our next step is to draw an axis. So we will use the conventional axis. Yung usual lang. X-axis will be horizontal, Y-axis will be vertical. This will be the positive X side, and this will be the positive Y side. So let's proceed in solving yung sum of forces along the X and Y. So this is an accelerating object, so we will use Newton's second law here. So the sum of forces along the X-axis is equal to the mass of object 1. So it is very important to specify kaninong mass ito. Since we are looking at the free body diagram of mass 1, let's put mass 1 here, which is 1 kilogram yan siya mamaya. And that is multiplied to the X component nung acceleration natin from this free body diagram. Now, if we look at itong free body diagram na ito, we can see that the X component of acceleration is actually A, no? So, yung A natin is along the X-axis and towards the positive direction. So, positive A dapat itong X component na acceleration. Now, what are the forces along the X-axis? The forces along the X-axis, we only have one, and that is the tension directed sa positive X. So, yung value niya should be positive. So, now we have T is equal to mass 1, and the value of the X component of acceleration is simply A. Now again, kung yung acceleration natin is pointed to the left, that will become negative. Pero since to the right naman siya nakaturo, then we will take a positive value for A. Okay? So, we have our final equation here. T is equal to m1 times A. Now, we will use this later, but we will label this as equation 1 for now para ma-refer natin siya later as we go to other equations. Now, let's go to the sum of forces along the y-axis. So, sum of forces along the y-axis is equal to mass 1, m1, times the y component ng ating acceleration. So, looking at our free body diagram, we have two forces along the y-axis. We have the normal force on the positive. So, we have positive eta. And then, we have the weight of mass 1, which is on the negative y direction. So, it will take a negative value, negative weight 1, which is equal to mass 1. And then, yung y component ng ating acceleration, if you look at our acceleration here, it is only along the x-axis. So, x-axis lang yung acceleration natin. Walang acceleration along the y-axis. So, the y component should be 0. Okay? Horizontal. Completely horizontal yung ating acceleration. So, 0 yung y component niya. One thing that we can do here is to transpose itong weight 1 to the other side. So, we have eta is equal to weight 1. Okay, so this is what we can get from the sum of forces along the y-axis. So, we will use this later again. So, let's label this as equation number 2. So, we'll proceed with the free body diagram nung mass number 2. So, we'll represent box number 2 as a dot. Then let's list down all the forces. The quickest one is yung weight ng mass number 2 natin. Tapos we have the tension. Now since same lang ito na string, we will use the same symbol for tension. It should be T, no? Para pareho sila ng tension from this tension here. Kasi isa lang yun sila na string. Now again, if the object is accelerating, it is useful to also draw yung direction ng acceleration. So for this case, the direction is downward and the magnitude is A. So yan yung acceleration ng mass number 2. So let's go to the components of the net force. The sum of forces along the x-axis, this is equal to mass of object 2, kasi nasa object 2 na tayo na free body diagram, times the x component of the acceleration. So if we look at our diagram, hindi pala natin nilagay yung axis, no? We'll use the conventional axis, x and y. Walang force along the x-axis. So this becomes 0. And then you have mass 2 times the x component ng acceleration. Now, if you look at yung acceleration, the acceleration is along the y-axis. Hindi siya along the x-axis. So, actually, its x component is equal to 0, which is true. 0 is equal to 0. So, actually, wala tayong makuhang equation from the sum of forces along the x-axis. So, we proceed with the sum of forces along the y-axis, and that should be equal to mass 2. Again, nasa free body diagram tayo ni mass number 2 times the y component of the acceleration. So, from our free body diagram, meron tayong dalawang forces along the y-axis. We have the tension, which is in the positive direction. So, we'll write that as a positive T. And then we have the weight of mass 2, which is directed downward, nasa negative y direction siya. So, we'll give it a sign that is negative. So, negative weight 2. And this is equal to mass 2 times, so let's try to see ano yung y component ng acceleration. So, again, our acceleration is along the y-axis, but this time, yung direction niya is downward. So, by our sign convention, downward should be negative. So, we'll put a negative sign. Tapos yung magnitude niya is A. So this time, the y component of our acceleration is negative A. Okay? So again, weight 2 is simply equal to the mass times the acceleration due to gravity, and this is for box 2. So we'll put m2 times g. So yan yung weight niya. And then we'll write the rest of the equation here. Now, can transpose itong term na ito to the other side. So, we have T is equal to M2G minus M2A. Now, meron tayong value for t, and that is written in equation 1. So ito yung value natin for t. So let's try to substitute that or insert that value from equation 1. So from equation 1, our tension is equal to mass 1 times acceleration. This is equal to, we write the rest of the equations here, mass 2 times gravity minus mass 2 times A. So again, for this problem, we are trying to solve for the value nung acceleration ng both objects. This A ang gusto nating i-solve. So in order to do that, we need to isolate yung variable na yon on one side and put the rest of the variables on the other side. So to do that, meron tayong A din kasi dito. So let's try transferring that to the other side of the equation. So we get M1A plus M2A, negative siya sa kabila, paglipat niya naging positive siya. And that is equal to mass 2 times G. Now, both have A, so we can factor out the acceleration here. So A is equal to mass 1 plus mass 2, or this is equal to M2G. Now, we just need to transpose this, and we can get the value for the acceleration A. So that is simply M2 over M1 plus M2 times the acceleration due to gravity, G. So ito na yung gagamitin natin na equation for the acceleration. So simply, substitute yung ating given values. So we have mass 2 is 1.20 kilograms. Tapos mass 1 is 1.00 kilogram. So 1 kilo lang siya. Plus we have mass 2 again, 1.20 kilogram. And then multiply that to the acceleration due to gravity, that is 9.81 meter per second squared. So if you plug this in to our calculator, we should get a value. Again, rounding off to 3 significant figures, we have 5.35 meter per second squared. So this is now the value for our acceleration. So that's it. So that's how we use Newton's second law in solving problems. So again, we still see yung mga approaches natin before. Draw yung direction along with our free body diagrams. We should draw yung direction ng ating acceleration. And instead of setting the sum of forces along x and y to be 0, meron na siyang value since may acceleration yung object natin. So some things that we need to be careful, kapag marami yung objects natin, we should be careful to indicate kaninong mass yung ilalagay natin dito sa ating equations. So if we are looking at the free body diagram of mass 1, so dapat mass nung object 1 ang ilalagay natin, and so on.